to our presentation. We are here to talk about the proposed improvements at US 33 and State Route 274. I'm Amy Havener, the ODOT project manager for this project. In a moment, I'll turn over the presentation to our design consultant. She'll discuss the conditions that led to this project, some of the past treatments implemented, options considered and dismissed, and the benefits of our current preferred alternative. But first, I want to talk briefly about how important you are to our process. ODOT has learned the hard way that public input makes for better projects. The people that use our system every day are alert to details that we may have overlooked, or they have suggestions for how to improve our system that we haven't considered. ODOT incorporates public input into its decision-making. We will not make a final decision on this project until we've taken another hard look at our project based on the public comments received and modified our alternative as necessary based on that input. We very much hope you will take the time to reach out to us with your comments, questions, and suggestions. We also hope that you understand that ODOT is under certain constraints. We have to operate consistent with the law. We have to operate consistent with sound engineering and design standards. We have to stay within the scope of the project, addressing safety concerns while maintaining acceptable operations at the intersection of US 33 and State Route 274. And we need to stay within our budget, both in terms of dollars and time. Suggestions from the public that do not fit those constraints probably can't be implemented. But if you don't ask, you'll never know. So give us your feedback. I'll be back at the end of the presentation to offer more details on how to provide feedback. In the meantime, I'll turn this presentation over to our design consultant.
All right, thanks, Amy. Hi there, my name is Abby Cueva, and I'm the Director of Transportation Planning and Design. I'm a project manager here at EMH&T, the design consultant ODOT selected for this project. And I'm going to be taking you through the presentation. We're going to start with the need for the project. We're also going to go over the history of some previous safety improvements that have been implemented at the intersection. I'm going to briefly discuss the other alternatives that we took a look at that were evaluated and dismissed, and how the recommended preferred alternative was selected. Benefits of a roundabout will be presented, and we'll also take a look at how traffic will be addressed during construction. And to wrap it up, we'll also lay out the estimated construction schedule. So the whole purpose of the project is to improve safety at the intersection. Not only do we want to reduce the total number of crashes, but we're really looking to reduce the high percentage of injury crashes at the intersection. The intersection of US 33 and State Route 274 was ranked number 37 in the entire state and on the 2021 safety ranking list for rural intersections. Over a 5-year period from 2016 to 2020, there were 18 crashes recorded, with 56% of those resulting in injuries. Angle crashes accounted for 50% of the total crashes. And as we often see with high injury rates, angle crashes are usually the cause of those. So ODOT has made some attempts to improve safety at the intersection over the course of probably about the last 30 years. Left turn lanes were added on US 33 back in 1996. In 2009, there were some sign recommendation updates done from a roadway safety audit, and those were implemented in 2009. And we also did some additional sign upgrades in 2013 at the intersections. So let's talk about some of the alternatives that we evaluated and dismissed. The first one, and this is kind of standard process for ODOT projects, is we want to compare to what we call a no build or do nothing alternative. And as the name indicates, this option simply leaves the intersection at its current condition with no improvements. This alternative was eliminated as it does not meet the project need to reduce the total number of crashes, particularly those injury crashes we talked about. And it was also found that the intersection will not meet the operational standards as traffic volumes continue to grow. And in this case, that means the folks that stop on State Route 274 are going to continue to experience increasing delays as traffic volumes continue to grow. The second alternative we took a look at was to install a traffic signal at the intersection. Although the traffic analysis showed that a signal would provide for acceptable operations at the intersection, the safety analysis showed that a signal will actually increase the number of total crashes by a factor of 2. Therefore, it was eliminated for not meeting the purpose and need of the project, which is to improve safety. The third alternative we looked at was to realign the existing intersection to reduce the severe skew that exists today and add turning lanes to State Route 274. This alternative pretty much matches the existing stop condition, and although it gives us a slight improvement in operations from the existing condition with the addition of those turn lanes, it makes little to no impact on improving the safety at the intersection. The fourth option we took a look at was to construct an overpass of 274 over US 33. Now, this option meets the purpose and need of the project at this location, as it essentially eliminates the intersection altogether. However, we must be mindful that the improvements at this intersection likely only shift traffic to other intersections and will potentially cause safety issues at those locations. Additionally, an overpass would cost over 2.5 times as much as the recommended preferred alternative. So this led ODOT and the EMH&T team to the recommended preferred alternative, the installation of a roundabout at the intersection of US 33 and 274. A roundabout is expected to reduce crashes by 52% and virtually eliminate those high-speed right-angle crashes. A roundabout provides a higher level of service versus the signalized option and requires less right-of-way versus the intersection realignment and overpass alternatives. This project will require some new right-of-way, and this is shown in the purple shaded areas on the exhibit above. Alternatives considered, the proposed roundabout was the only alternative to have a positive benefit to cost ratio, which means that number is greater than 1. A benefit to cost ratio of 1.12 indicates that the expected cost benefit from the reduction of crashes will be greater than the construction cost of the project. Let's talk a little bit about roundabout benefits and how they do improve safety at an intersection. In a nutshell, they really reduce conflict points. As you can see on the screen, a standard traditional intersection has 32 different conflict points, and a lot of those being those right angle crashes that we talked about earlier. And a roundabout reduces those conflict points to 8 and eliminates those high-speed right angle and head-on collisions. Crashes are usually slow speed or side swipes, which decrease the severity of crashes when they do occur. The Federal Highway Administration studies suggest that roundabouts on rural intersections reduce all crashes by 52%. In addition, when this is huge, they reduce injury crashes by up to 88%. You can find the Federal Highway Administration's rural roundabout information on ODOT District 7's website. Roundabouts also will improve the operational performance at the intersection. Delay will be reduced when compared to all the build alternatives, with the exception of the overpass. Finally, roundabouts are just good for the environment. They reduce emissions since most vehicles will not have to stop. So how do we navigate a roundabout? There are a few simple steps to safely driving through a roundabout. First, you want to slow down. And a lot of times we introduce geometry on the approaches to help folks slow down. You look to the left and you simply yield to vehicles already inside the roundabout. And once you're inside the roundabout, you have the right of way. So you keep moving and exit the roundabout at your desired location. I also want to mention that we have posted some informational videos on the project site that will give you a visualization on how to navigate a roundabout if you would like to take a look. I encourage you to visit the project website, and we'll be sharing the link at the end of the presentation. So a concern that we often hear, particularly in rural areas and those less familiar with roundabouts, pertains to farm equipment navigating the roundabout. And we take great care when we're designing the roundabout to accommodate the needs of the area. We utilize rolled curb that is able to be traversed by larger vehicles, concrete aprons, and reinforced outside shoulder widths, often referred to as blister islands, to handle the larger turning paths. This allows us to simultaneously control speeds through the roundabout while also providing the extra width needed for these larger vehicles. Again, on the project website, we have some videos similar to what you see on the screen. This is actually the location of the US 33 and 274 rendering, what it's actually going to look like once it's constructed. Not only do we have semi-tracks simulated. We also have done a couple of different pieces of farm equipment that you can take a look at. So during construction, through traffic on US 33 will be maintained for the majority of construction, but weekend closures are likely and are to be expected. Additionally, movements to and from 274 will be unavailable as shown on your screen. So the official sign detour will utilize state routes as shown on the screen. So if travelers heading east from the west, the detour will be State Route 235 north to State Route 708, north to US 33 east to 117 north, back onto State Route 274 east. It's kind of the yellow highlighted path you see on your screen. However, as is often the case, there are local roads around the intersection that are expected to facilitate a local unsigned detour for traffic currently using the 33 and 274 intersection. It is expected that movements to and from State Route 274 will be restricted for approximately 90 days. So what's our schedule look like? ODOT's going to be taking comments from the public until July 31st, 2024. The preferred alternative will then be determined by September of this year. Design is expected to be completed by October 2025, with construction anticipated in the spring and summer of 2026. Now that concludes my portion of the presentation. And with that, I will turn it back over to Amy.
To provide comments via ODOT's webpage, you can either scan the QR code to the right of the project or go to ODOT's webpage, www.transportation.ohio.gov/projects. In the search link, you can type in the PID number, which is 118109, and click submit. And then you can click on leave the comment button. Or you can also call or email myself or Tricia Bishop, the District Environmental Coordinator. Comments are requested by July 31st to ensure your comments are considered in the decision-making process. We really hope to hear from you. Our projects are better with your input. We will also issue a follow-up announcement to our final decision regarding a preferred alternative after we have had an opportunity to consider comments received. If you were on a previous mailing, or if you provide your mailing email address with your comments, you will be included on that announcement. You can also check back on the ODOT project page. Please understand that our final decision may take several months, as additional research or study may be needed based on comments received. We want to make the best possible decision. Thank you for your time and interest in this important project.